I have this old motor and it's barely been used. It's 3450 RPM, single horsepower. I'm going to need a slow speed grinder to sharpen my turning tools, so I decided to use this to build one. I didn't have bolts long enough to go through my plywood to mount the motor, so I just put threaded inserts in. I ran them in from the back to ensure that I can tighten the motor down as tight as I want it without pulling the inserts out. So I got the holes drilled for my cotter pins. Yeah, there we go. So the motor will hinge like that. I am making a jig to hold my steel rod so I can drill it centered. I think I learned this method from Tim Keel. I have to go back and check his video. He made some sort of jig for drilling the center of a dowel. To be able to clamp this block to the metal part of my table. Well, I can only cut threads in this one side until I get a reverse thread tap. But I've only got one cutting wheel right now, so doesn't really matter. I couldn't mount one on the other side anyway. I'll be installing C-clips as retainers on the inside of the bearing. I'm using the block that I use for a drilling guide for the shaft to hold the shaft in place so I can mark where I need to cut the groove for the C-clip. So my hacksaw blade wasn't wide enough for the C-clip, but a reciprocating saw is. After I scored a line all the way around with the hacksaw, I was able to come back and drop the blade of the reciprocating saw into that score and use it as a guide to keep me from sliding all over the place. Basically what I'm going for is a groove 1/16 of an inch deep all the way around to take this 5/8 shaft down to 1/2 inch, which is what the inside of the C-clip measures, and I think I'm almost there. Would you look at that? Alright, only 4 more to go. Well, I need to drill all the way through this plywood so I can run a threaded rod through it. I made a jig, a drilling jig, to help me stay centered and to stay straight. I'm wondering now if routing the channel down through there might be a better option. I already tried this once and it didn't work out. The bit wound up busting out the side. Alright, maybe that'll work. Yeah, it's going through now. Well, alright, that problem solved. I was wondering if I was going to be able to make this work. So I've got both my side support bearing blocks screwed together. I did that so I could cut them perfectly square and exactly the same size, and so I could drill the bearing holes in the exact same place, because I don't want the shaft to be tweaked, racked, whatever. If it's not very straight, it's going to bind up the bearings, and I want this thing to roll as freely as possible. So this is the best way I could figure out to do that. I got my depth gauge set, or depth stops, so I shouldn't drill into my table. Yes, I can see it. Okay. I got to drill some recesses in the end of my board so the nuts that I'm going to lock the threaded rod with will have a place to go. I'll be sticking out. Alright, it looks roughly even. Put a little thread locker on here to help ensure that these nuts don't come loose. I'll be using two of these, one on each side, for thrust washers, basically to keep the bearing from pushing out. Even though I've got it locked down, I still don't want to take a chance of it working its way out. But the problem with these, the hole is too small. They'll be hitting against the inner race of the bearing, so I'm going to come back and grind out some of this middle, taper it so it can't touch the race. I want it to be able to hit flush against the outer race, but I don't want the bearing binding up on it. I honestly do not know how this switch is supposed to be wired or if it matters. On the RAS, I've got the power going into the left side of the switch and the machine wires coming out of the right side, and I've got the neutrals on the top set of screws and the hots on the bottom set of screws. It works. I haven't had any trouble with it, so I'm going to wire this one the same way. I mean, it may not matter, but I don't know, because like I said, I don't have any instructions with this switch. So might as well use what I've already tried and know works. Something a little harder than my fingers to snap them on with. There we go. Everything has to go in the right order. This little red rubber washer is a garden hose washer. I'm using rubber washers on each side of the grinding wheel to give some grip, because the shaft is just a little loose. The grinding wheel slides on it, and just clamping it down between two metal washers doesn't seem to be providing enough grip. And I need to tighten down the bearing block. So the bearing won't spin. Okay, I'm gonna plug this thing in, try this new switch out. It should be off, let's see, yes. The vibration seems to be coming from the motor, not the grinding wheel part. I'll have to test it out on something to make sure, but I don't think there's any run out in this. Doesn't look like it. Built a belt guard that I will be putting on the top. I wanted to test this thing out and make sure the vibration I'm hearing is just the motor bouncing. I went ahead and put the belt guard on. I'm going to try to stand over to the side while I do this. Yeah, I'm not getting any vibration at all in the grinding wheel itself. I went ahead and set up the shaft on the other side to take another wheel. This is a 320. Before I can mount a grinding wheel on this side, I've got to find a reverse thread 1/4 by 20 tap, and I have to get a reverse thread bolt before. If you're building a setup like this yourself and you don't have all this scrap metal and miscellaneous parts lying around, you could do something with wood. Just cut a piece of plywood and cut a slot in it and use a locking knob and a couple of threaded inserts, one on each side. That would work as well. Probably be a heck of a lot easier than what I went through. I've made several little tweaks to my setup. You see the screws that are holding the conduit brackets to my motor mounting board. Well, I have washers between the brackets and the board to make the conduit easier to put through, but I took those out and tightened that up so it's not wobbling around as much, and that's helped the vibration some. I added rubber grommets on the top and the bottom of my motor locking setup, and that has helped reduce some of the vibration. I opened up the back of my belt slot a little wider. I had it too narrow and the belt was bumping on the plywood, making some noise. I noticed a clicking noise when the grinder was winding down, and I realized it's because my bearings are not tight enough on the shaft. So I've just taken a center punch and made a series of 8 little dings in the shaft, each equally spaced, and I put 2 side by side on the area where the bearing rides, and that's tightening the bearing up enough that I'm having to press it on, but that will keep it from vibrating. Tightening the bearings on the shaft and the other little tweaks I've made have really reduced the vibration and the racket this thing's making. I think I'm going to be pretty happy with it the way it is. that's about as good as I'm going to get it, and I think it's perfectly fine. According to my research, CBN wheels don't require a guard. Since they're made of solid metal, they're not prone to flying apart like the regular stone type wheels. Now, I'm not suggesting that if you build one that you run it without a guard. You need to do your own research and make sure, don't take my word for it, but that's why I'm not putting a guard on this. I really don't think it needs it. I've still got to build a tool rest for this so I can sharpen my tools at the correct angle, but that's going to have to be another video because this one's already way too long. Okay, I think that's it. Thanks for watching.